Okay, class. So today we're going to talk about the distance formula. Okay, so the first thing I'm going to do is I'm going to discuss how, to recall that when we find the distance between two numbers on the number line, it's a positive value. So in this case here, it's always going to be involved in absolute values. So if we wanted the distance between these 2 points, point Q, point P, and point Q, then we would write the distance PQ is going to equal the absolute value of the distance between these two, the difference between them. So it would be x2 minus x1 or x1 minus x2 because we're taking the absolute value of it. So it doesn't matter which way we subtract them. Okay? So this is how we would calculate the distance between two numbers on the real number line. Okay, so now let's take this one step further and say, okay, what if I had 2 points on the coordinate system? Okay, and I wanted to find the distance between the points. Well, in this example over here, we have this point here, which we call x1, y1. Okay. And then we've got this point over here, which is x2, y1. So this is straight across from here. Okay. And then down here we got the third point, which is we're called x2, y2. Okay, so we've got these 3 points, and as you can see, it makes a right triangle. Okay. And so we can find the distance between these 2 points and these 2 points. And then, but what about these 2 points? Okay, because this is on the number line here, right? So this is just going across, just like this one. These two are straight vertical, so we could just take the difference going along the y-axis, but this one is a little different. Okay, so let's do a couple of examples. So if I had, for example, let's do one on here. Let's say this is 8 and this is 3. And so we would say the distance PQ is equal to the absolute value of, well, we could do 3 minus 8. Oops, hold on, got this backwards. So 3 and 8. So we could do 8 minus 3, which is going to give us what? It's going to give us an absolute value of 5, which is just 5. Or we could do the absolute value of 3 minus 8, which is going to give us the absolute value of negative 5, which still gives us 5. So we get the same thing. Okay? So now let's look at this. Well, if I was looking at this right triangle, the first thing I would think of is this one we can get, right? Because this is, what is this? This is going from x1 to x2, right? Along the x-axis. So I can just subtract, take the absolute value of the difference between the x values, right? So this here can be represented as the absolute value of what? x2 minus x1, right? And then this one here, well, what's the difference? These are vertical, right? So these are like as if they were on this line here. So the only difference between the distance of this point is the y values. So I can write this as the absolute value of y2 minus y1. Okay? And then so what I can do is then I can use the Pythagorean theorem to find that distance. So what can I do? What does the Pythagorean theorem say? The Pythagorean theorem says, well, let me write this down. So let's call this A, we'll call this B, and we'll call this C. And the Pythagorean theorem says if I have a right triangle, then the relationship between the sides is a squared plus b squared equals c squared. So if I look at this, well, a is just this, right? So a is going to be the absolute value of x squared minus, or x1 minus x, excuse me, x2 minus x1, quantity squared, plus b, which is this one, the absolute value of y2 minus y1, quantity squared. Okay? And so that has to equal what? That has to equal c squared. Well, what's c squared? Well, that's what we're trying to figure out, right? We're trying to figure out what c is, the hypotenuse. And so what happens? Well, the first thing to notice is that since we're squaring these, we can drop the absolute values. Okay? So let's rewrite these just without the absolute values. So it's going to be x2 minus x1 squared plus y2 minus y1 squared equals c squared. Now, all I have to do now is take the square root of both sides and I'm done. And so if I take the square root of both sides, I get c, which is what I'm looking for, equal to the square root of this difference squared plus this difference squared. And that gives me the formula for the distance formula. That means that I can take any 2 points on the coordinate system, right? So I can take any 2 points and I can find a point anywhere else that can make into a right triangle. And I can use this formula that just involves these 2 points now, right? I can just plug in the points here. If I have 2 points and I use this distance formula, I can find the distance between any 2 points on the coordinate system. So that gives us the distance of any value if we have PQ. Okay, distance PQ, oops, sorry, lowercase d. Distance PQ is equal to x2 minus x1 squared plus y2 minus y1 squared. And this gives us the distance formula. Okay, so let's do an example where how we would work this. So let's change these numbers. Oops. So let's put the numbers in and see how this works. Okay. So let's say I have 3 points. Let's call this, we'll call this point P, call this point Q, and we'll call this point R. And we're going to say that P is at negative 4, 3, so negative 4, 3, okay? And this point here is at 8, comma 3, and R is located at 8, negative 2, okay? So now let's use the distance formula to find the distance between PQ. Well, the distance between PQ is just going to be what? It's going to be this, the absolute value of this minus this, right? So the distance is going to be 11, right? So that's easy. The distance between these two are going to be the difference in the y values because we're going vertical in the y direction. So that's going to be this minus this, so the distance is going to be 5. But what about these 2 points? Okay, they're not horizontal and they're not vertical. Well, this is where the distance formula for any 2 points comes in. Okay, and by the way, the distance formula will work for these two as well. But the difference between in this case here, if we're going horizontal, the difference in the y's is 0. So these go away, okay? So it'll work for all points, even vertical and horizontal ones. Okay, so let's find PR. Let's find the distance PR. So distance PR, well, that's going to be equal to x2 minus x1, oops, squared, plus y2 minus y1 squared. And now let's plug in the values. So x2, and then here's the thing, whatever x2 and x1 is, just be consistent. So let's do this, the first point. So this will be x1, and this will be x2. So we're going to do 8 minus a negative 4, okay? So be careful of the signs. So this is going to be 8 minus a negative 4 squared, plus, now the difference in the y's is going to be, okay, well, if 8 is x2, then we're going to have negative 2 be y2. So it's going to be negative 2 minus 3. Squared. Okay? And now we just simplify this. So this is going to be the square root of 8 plus 4, right, which is going to give me what? 12 squared, plus negative 5 squared, right? So far, so good? Okay, and so now if we simplify it even further, what do we get? We get 144 plus 25, which just gives us the square root of what? 169. Okay, and what's the square root of 169? It's going to be 13. Okay, so the distance of PR, distance PR, equals 13 units. And we're done. And that's how you use the distance formula.